Hello everyone, welcome to series of lectures on local search algorithms. Today we discuss about the genetic algorithms. In last two sessions we discussed about hill climbing algorithms and simulating annealing algorithms. Next important algorithm in this series is genetic algorithms. So genetic algorithms are a heuristic searching algorithms that is inspired by Charles Darwin's theory of natural evolution. So Charles Darwin's theory says that only fittest people, like survival of the fittest taken as the natural selections for reproducing the next generation. The same concept we applied in our searching solutions for AI problems. Our local search algorithm follows this analogous with the help of genetic algorithms. So genetic algorithms they are widely used in real world application like image processing, designing electronic circuit, code breaking and artificial creativity. So what is the genetic algorithm? See, now genetic, like a natural evaluation, how a natural evaluation is taken place as per Darwin's theory. First we create a population, first we select a random initial population, and from that population we take a sample and we find out the fittest of that sample, who are the fittest people in that sample. By selecting those fittest people, we perform some crossover. So this crossover of fittest people gives the new offsprings who has the highest potential than their previous generation. So after this cross offsprings, what we do, we apply some mutations in those offsprings so that additional features or abilities can be given like through the mutations. Means some features, if we want, we can mutate them, and after that we replace the old generation with the new generation, and after a certain number of generation we terminate the process. That is how natural evolution works according to the Darwin theory. Now same in case of here he talked about population, now here we talk about the solutions. Suppose a algorithm has a problem may have solutions, a population of solutions. Out of those population of solutions, we take the solutions, calculate their fitness through a fitness function, and after fitness function, based on the output of the fitness function, we select the solutions, and then those solutions are crossed over, means crossed over to create a offsprings, new kind of a solutions. And we make smaller changes in those solutions through mutations, and finally we apply the new solutions to the problem. The same means finally, unlike your hill climbing and simulating annealing problems, where a solution is taken, it is improvised over the time with given inputs, and that we optimize the solution, we try to give that solution to the problem. But here in these genetic algorithms, we take a set of the solutions and we find the fittest of the solutions, we cross over and generate a new solutions through offsprings. Now how this works? So let us see, it's a flow chart of how a genetic algorithms works. First we initialize the population, compute the fitness, we take the fitness function output, we give some criteria. If yes, we end. If no, again we parent the selection, crossover, mutation, compute fitness, and again we go for decision. If yes, then we end. The whatever I have told, that is given in a diagrammatic representation. Now let us see how it is done. First step in this genetic algorithm is initial population. So there are 4 populations, so A1, A2, A3, A4. Here we say not as a population, as 4 solutions of our problem. Each individual is a solution to the problem. each individual combined by the two characters like 0 and 1, we treat them as a genes of my problem, and these combination of the genes together form as a chromosomes. Like in our biological evolution, individual bits we call them as a genes, combination of the genes we call them as a chromosomes, collection of all these chromosomes within these structures we call them as populations. So that is the first step. After that, we calculate the fitness of each population, each solution, whether A1 is fit for it. Shall I select A1, A2 or A3? We select some solution, we perform the crossover. So fitness, we calculate the fitness score to each individual. So once they successfully successfully completed their fitness score, now they become eligible for reproduction. Those solutions, here not a people are talking about a solution, those solutions again reproduced with the new offsprings. So we perform the selection of the individuals based on their fitness score, and then we perform the crossover of these parents. These two parents are selected according to their fitness, and I perform a crossover. Crossover means genes of this A1 parent combined with genes of A2 parent. A2 parent genes are combined with A1 parent. So like this 0 0 0 1 concatenated with 1 1 1, 1 1 1 concatenated with 0 0 0. Like this we cross over the parents and we generate the offsprings. Like these two offsprings are created. So crossover, generally crossover at a particular point we set the crossover. So here I set the 3 point, means from this 3 point these my genes are crossed over in chromosomes, right? Now I can select a 2 point crossover, 1 point crossover, 4 point crossover. I have to set the point for a crossover. Next, offsprings. Once offsprings are means parents they crossed and new offsprings are generated. Then we apply the mutations. Mutations are applied for getting a better solutions. Like means a small change in the genes may, like your human evaluation also. Sometimes because of mutations, new diseases they arrive, and because of mutations, sometimes our immune system goes strong. We used to learn about this during corona virus is getting mutated, means every day new generation of that virus is being generated. Now the same thing here also, mutation is performed between the birth, just you swap those data. This step we call it as a offspring and mutations. The algorithm terminates if the population has coverage does not produce offspring which are significantly different from the previous. Means offsprings are iteratingly they are look-alike like their parents, then no need to again go for a generation of a new offsprings. We stop our program. Now this logic, whatever logic that I told you about finding the solution, finding the fitness score, and selection of the solutions that eligible through fitness score, crossover of the solutions, offspring, generation of offsprings and mutation of the offsprings, and termination of the generation. These things now we apply in our AI programming. In next session I solve one problem, how these concepts like selection, fitness score, crossover, offsprings help us to solve any AI algorithm, search for a solution of a given problem. Thank you.